Hey, lesson 58. We're learning to multiply polynomials using the distributive property. Now, what we just did in the bell work was multiplying monomials times polynomials. Today we're going to be multiplying polynomials times polynomials. Two things by two things by three things. Now, the good news is that it still uses the distributive property, still uses the laws of exponents, everything that we're familiar with. So this is a really a pretty easy lesson in the grand scheme of things. All right, so learning to multiply polynomials. By polynomials, we mean sometimes what we just did was technically polynomials, but that's monomial times a polynomial. We're going to be multiplying polynomials by polynomials here. Lesson 58. We'll do lesson 59 tomorrow. Lesson 60 on Thursday. Probably going to have a test a week from Thursday. Unit 6 test.
Yes.
Okay. All right. Now we'll start Unit 7 before we get to that test, but Thursday's a good day for a test. All right, so what do we get? This is not new, that we just did these types of problems in bell work. I'm just reminding you what the distributive property tells us we have to do. 3x times x squared and 3x times y. You can sit there, Elijah, that's fine. We get 3x cubed plus 3xy, correct? Is there anything else that can be done to that expression? Why not? Because these terms are not like terms, we can't do anything else to it. So what will we have on the next problem, Abby? What will we get for letter B here?
We'll have negative 4x cubed y plus, minus 4xy squared plus 8xyz squared.
Perfect. Okay. Careful that negative times negative is positive, negative times positive is negative. If you multiply two terms with the same sign, then you get a positive product. Different signs gives you a negative product. All right, so that's not new. We've been doing that all year long. Now, the distributive property, just some notes, the distributive property extends to multiplying more than just monomials. If you have a binomial times another polynomial, you simply apply the distributive property to each term in the first polynomial, to each term in the second polynomial. All right, so this is where you guys called it the FOIL method last year probably. I don't use that acrostic much because it doesn't apply. It only applies to two terms times two terms. Right? It doesn't apply to two terms by three terms. So I want you to kind of think of this as using the distributive property. We just have to distribute twice if we have a binomial that's multiplying another polynomial. All right? We'll distribute two times however many. And in this case, we're distributing two terms to two terms, right? A binomial times a binomial. So start by distributing the x. What will we get when we distribute the x? That's x squared. X times 3 is 3x. I want to see this process too. I want y'all to notice what I'm doing here because when I teach you how to undo these things, this is going to be important. 7 times x is 7x, and then 7 times 3 is 21. Now finally we can do 3x plus 7x gives us 10x plus 21. Now, the difficult part of this process is working backwards. It's coming a little bit later in the year, but we're going to factor expressions like this. What kind of expression is this? It's a second degree trinomial. It's also called a quadratic trinomial. Okay? It's an important thing to be able to recognize. Do you see any relationship between the answer and the problem? You see any kind of patterns or anything that exist there?
The two
The two constants.
Constants. Multiply out to 29.
And,
The two x's get x squared.
all right, what else?
A constant.
The sum of the two constants is 10. So we've got the sum of the two constants here and the product of the two constants there. All right, and we're always looking for patterns in mathematics, things that we can use to help ourselves out, right? So we'll see if that product kind of becomes familiar. If it holds true, then what will we be looking at in our final answer here? What's the product of -5 and -7?
35.
Positive 35. What's the sum of -5 and -7? -12. So will it work? Let's see. X times x, we're distributing twice. We're going to distribute the x. That's x squared. That's -7x. That's -5x. And this is positive 35. Combine those two, and we get x squared minus 12x plus 35. All right? The pattern holds again. The product of -5 and -7 is positive 35. The sum of -5 and -7 is -12. Okay? This one's a little different, isn't it? So we got some other values or some other coefficients in the mix in this problem. Work this one out and see what you get. Okay? Well, what do we get there?
6a squared plus 17a.
All right. Now there's patterns here, but they're not as easy to find. Does anybody see any patterns?
2 times 3 is 6.
Yeah, that's...
That's what we... What's the pattern?
3 times 5 plus.
All right, let me...
5 times 3 plus 2 is 17.
That's literally what I just said.
Yeah. All right, so let's have a look at the answer to the original problem, or the answer to the process. And I'm going to ask you to pay attention to this. What is 6 times 5? 30. You see anything else anywhere that ties into 30?
5 times 2.
2 times 15 is also 30.
This is my defense.
Okay, so 2 times 15 is also 30. Now, looking for patterns like that and things like that, you know, it's kind of what we're talking about, the analysis of functions, the analysis of things, analyzing it, see if we can find any patterns or things that might be helpful to us a little bit later. Try this one. Got to be careful with signs on this one. But if we multiply, distribute, 8k times -3k is -24k squared, -24 carats squared. Not to be confused with -24 carats squared. -40k plus 3k. Be careful with signs. Negative times negative is positive. And then plus 5. All right. Now, that'll give us -24k squared minus 37k plus 5. Now, the pattern that we found last time was to multiply these two things. What do we get?
I'm just gonna go on a limb and say negative 120.
Negative 120. And what happens if you multiply these two things? We also get negative 120. So the same pattern exists that we looked at just a second ago. This pattern, y'all listen, this pattern is going to be very, very important to us when we work backwards, when we factor these quadratic trinomials, second-degree trinomials. When you factor them, the process in reverse is going to kind of be the same. It's, just a reverse process. You're unfoiling the expression. So we're looking for ways to make it work. All right, now this is different. What should we expect to have after we multiply this first expression? How many terms? 6 terms, right? Because we're multiplying 2 terms by 3 terms. So we're going to get 3 terms from each product. Start with the 3x. What's 3x times x squared? 3x cubed. 3x times negative 4x. Negative 12x squared. 3x times negative 6 is negative 18x. I'm going to show you a little paper saver. All right. What's 4 times x squared? Positive 4x squared. You can go ahead and write that one right underneath that other one. Why would we do that? Because they're like terms anyway, right? 4x times negative 4x is negative 16x. Those are like terms, so pair them up. And then 4 times negative 6 is negative 24. Now combine like terms. What's negative 12x squared plus 4x? Negative 8x is correct. 8x squared, sorry. Negative 18 minus 16. Same sign, add and keep. Negative 34x. Negative 24 just comes down. We're not looking for any patterns there because you're not going to factor, you wouldn't be able to factor this one. It's a little advanced for any level of factorization. You have to do separation of variables, and you don't want to do that. All right. What is this? Fournomial. Yeah, it's a fournomial. Or you could just call it a third-degree polynomial. Okay. A 4 term is not a quadrinomial. It's not really a. It's a fournomial or a fivenomial but it's a third-degree polynomial. All right. Last example. Find the area of a rectangular sandbox that has a width of 2x squared plus 5x minus 6 and a length of 4x plus 7. Now, it's not absolutely necessary in this particular problem, but I want to tell you that there's extreme value to always drawing a picture. Always draw a picture, okay? We've got a rectangular sandbox that has a width of 2x squared plus 5x plus 6 and a length of 4x plus 7. It is minus 6, okay? Find the area. The area is equal to the length times the width, or width times length. It doesn't matter. You could do this however you want it to do. So 4x plus 7 times 2x squared plus 5x minus 6 is equal to 8x cubed plus 20x squared minus 24x. I'm a full-grown math student, and I still draw these lines if I was working a problem like this. So you don't forget anything, right? 7 times 2x squared is 14x squared. Let's put that underneath. Save some paper. And 14x squared. 7 times 5x is positive 35x. 7 times negative 6 is negative 42. So our area is 8x cubed plus 34x squared plus 11x minus 42 inches squared. All right. Any questions? It's really a pretty easy lesson. What's your question, Josh?
If you have something like that, but it's a really simple problem, would the inches squared technically make it a second degree, or?
Area is a two-dimensional thing. That's why you're just about always going to get a second degree in there.
What is a snowflake 4 by 120
That's the asterisk. Because it's for honors classes only.
We were all happy with the way it goes.
By the way, you guys know that is called an...
Snowflake.
It's called a what?
Snowflake. Asterisk.
It's asterisk. Not asterisk. Spelling bee for you right there.